In this video for section 3.3, we're going to look at the center of a distribution or a data set. One way to calculate the center of a distribution is to calculate the mean. To find the mean, you add all the values of the variable and divide by the number of values that you have. We have this symbol here. This is called x bar. And x bar represents the sample mean. So if our data come from a sample and we calculate the mean, then we can use the symbol x bar to represent that mean. The mean is a good summary for a unimodal symmetric distribution. We're going to talk a little bit more later about the relationship between the measure of center and the shape of the distribution. The mean is affected by extreme values or outliers, and we're going to talk more about that in a minute as well. So to find the mean of the data set, what we're going to do is add all our numbers and divide by how many numbers you have. So for this data set, I would be adding 10.3 plus 13.6 plus 14.2 plus 12.8 plus 11.9. And there are 5 values here. So I'm going to add all those up and divide by 5. The sum of those 5 numbers is 62.8. Probably you would want to use a calculator for that, and then divide by 5, and you would get 12.56. So that's the mean of the data set. What we're going to do next is find the mean of the same data set with one additional value. So you see here I have the same exact values for the first 5 numbers, but I'm adding a 102. So the question is, what does that 102, what effect does that have on the mean? So now I'm going to add up those numbers again. So we have 10.3 plus 13.6 plus 14.2 plus 12.8 plus 11.9 plus 102. And now I'm dividing by 6, since I have 6 numbers now. So when I add up those numbers, that gives me a total of 164.8. And when I divide that by 6, I get 27.47. Now, adding the value 102 had a significant effect on the mean. The mean went from 12.56 to 27.47. Now, the mean of 27 is actually greater than all of the data values except for the 102. So what this did is it made the mean a lot bigger to add in a value that was significantly larger than all of the other values. So the 102 here we could consider an outlier. The outlier 102 had a pretty significant effect on the mean. It made the mean more than twice what it was before the value 102 was added. Next, we're going to look at the median. The median is the middle value of a data set once the data are listed in numerical order. So that's important. We want to make sure that the numbers are in order from smallest to biggest. If the distribution is skewed, contains gaps or outliers, then it's better to use the median instead of the mean as a measure of center. The median is resistant to outliers, so the outliers typically don't affect the value of the median very much, and we're going to see that in a minute. Once you have the data listed in order, if the number of data values that you have is odd, you can take the exact middle value. If it's even, you'll have 2 numbers in the middle, and you need to find the average of those 2 values. So we're going to do some examples here. So what I need to do first, since these numbers are not in order, is rewrite them so that they are. So 10.3 is the smallest, followed by 11.9, followed by 12.8, and then 13.6, and 14.2 is the largest. Now I have 5 numbers here. One way that this is often taught is by a method where you cross out one from each side until you get to the middle. So my median value here is 12.8. That's exactly in the middle of the data set. Now we're going to calculate the median of the new data set with the value 102 added. So again, I need to put the numbers in order first, from smallest to biggest. So do that first. 14.2, and then 102 is the largest value. And then by the same method, I can cross off one from each side until I get to the middle. Now there's two values in the middle, the 12.8 and the 13.6. And so I need to find the average of those two values. So I need to add 12.8 plus 13.6 and divide by 2. So when I add those two numbers together, I get 26.4. And 26.4 divided by 2 is 13.2. So my median did change a little bit when I added the value of 102, but it did not change a whole lot. It only went up by 0.4. So the value of 102 did not have much of an effect on the median. And the reason why that is because if I look at where the 102 fell, it was on the end because it was much greater than the rest of the values. So if I add a number that's much greater or much smaller than all of the rest of the data, when I calculate the median, I'm just crossing that number off. So it doesn't matter if it's 50 or 100 or 1,000 or 10,000, it's just going to get crossed off the very first time that I cross numbers off. So any large number here, it doesn't matter what the value is, it's not going to affect the median that much. So we say that the median is resistant to outliers because it's not affected by them. We say that the mean is not resistant to outliers because it is affected by them. And so now we're going to look at the connection between mean, median, and the shape of the distribution. If the distribution is symmetric, then the mean and the median are going to be approximately equal in the center of the distribution. If the distribution is skewed left, remember that the mean is affected by outliers and the median isn't. So these numbers here at the left side or in the tail of the distribution, they're going to affect the mean, but they're not going to affect the median. And the result of that is that they're going to pull the mean to the left or so that it's smaller than the median. So I would expect if the distribution is skewed left, that when I calculate the mean, I'm going to get a smaller number than when I calculate the median. Again, for symmetric, they're going to be approximately the same. Probably not exactly the same numbers, but they'll be pretty close. And if the distribution is skewed right, my tail is on the right, that means that I have numbers here that are much bigger than the rest of the data. And so those numbers are going to affect the mean, they're not going to affect the median. And so that's going to pull the mean to the right, so the mean is going to be bigger than the median. The mean follows the tail. So whichever side the tail is on, if the tail is on the right side, it will pull the mean bigger. If the tail is on the left side, it'll pull the mean smaller. So here's another example with this histogram. This is monthly trading volume of AIG shares. And so if I look at this, this is a tail on the right side. And so what that's going to do is pull the mean up so that it's greater than the median. Or I can go in the other direction. If I know the mean and the median, so in this case, the mean is 170.1 and the median is 135.9 million shares. So since the mean is greater than the median, that tells me that the distribution is going to look like this. So it's going to be skewed right. The last thing that we're going to talk about in this section is mode. In statistics, generally in elementary school, you learn mean, median, mode. The mode is not actually used very much by like actual statisticians. It's the value that occurs most often in the data set. It's not affected by extreme values. Unlike mean and median, there could be no mode or there could be several modes. And also, unlike mean and median, it can also be used for categorical data. So looking at this data set, there's no value that occurs most often because each value occurs exactly once. In the second data set, the value 4.9 occurs 3 times, and so that is the mode. In the third data set, we have the value 28 occurring twice and the value 43 occurring twice. And so that's sort of like a tie. There's 2 modes because there's 2 values that occur more than the rest of the values. Now you have to be kind of careful here because we also use the word mode to stand for peaks in the distribution, like we saw back in section 3.1. So this is the numerical mode when we're looking at the numbers in a data set. You don't want to get it confused with the number of peaks when we're looking at the graph of a data set.